dear students. Hope so you are fine and enjoying digital classes nowadays. Dear students, as yesterday in my video I have told you about the introduction of D block elements. So today in this particular video I am going to tell you about the characteristics of D block elements. Okay, so stay tuned and just focus on each and every slide. So dear students, it is already told to you that we are going to study about D block elements, and it is yesterday I told group number 13 to 12. Between S block and between P block, the block which is present in periodic table is known as D block element. It is also known as transition elements, and all the elements are mostly metallic properties. So it is a pure metal and hence it has some special properties also. So we are going to study those properties, but before that there are F block elements also, which is there the second part of this unit that we will study after D block elements. Okay, so in D block elements we are going to study about period 14, 4th, 5th, 6th and 7th, which is group number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And in group 4th, group 3rd and period 4 is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, and these are the first member of D block elements. So after D block elements, let's start the basic characteristics with the definitions. So first define D block elements. So D block elements are the element of periodic table which belongs to the group 3 to 12, which is known as D block element, because in these elements last electrons enter in D subshell or D orbital. Why these elements are known as D block elements? Because the last electron that enter in D subshell or D orbital, the D block elements lies between S and P element in the long periodic table. Already I have told you. So if we will talk about the basic members of D block elements, so we have this is Z4S3D. It means that we have fourth period. In fourth period, the first series that left to right we are studying, that is scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. So there are some shortcuts or mnemonics that is we need to learn just to keep these members in our mind. That is Sachin Tendulkar. Suppose Sachin Tendulkar, very crazy man for coaching, giving free coaching to Nitin's cousin. Okay, like this way. So group number 5th is like yttrium, zirconium, neodymium, like this. So group number 16 is from lanthanide, and group 7 period 7 is actinide, not group, period, sorry. So once we understood learn the all these members, then we are going to move forward. These are called basically transition elements. Why these are called transition element? Because a transition element is defined as the one which has incompletely filled d orbital in its ground state or in any one of its oxidation state. It means that why these are known as transition element? Because it have incompletely filled d orbitals, underline this, in the ground state, or any other in its oxidation state. So transition element should have partially filled. This is the meaning of transition elements: partially filled n-1d orbitals. Okay, so next is electronic configuration. Basically general configuration is n-1 d 1 to 10 ns2. This is the general configuration. Now why n-1 is written? So let me explain this. If we will talk about scandium, titanium, vanadium, chromium, manganese, okay, like this way. So scandium atomic number is 21, so it means that the configuration will become 3d1 4s2. Similar with titanium, 3d2 4s2, vanadium 3d3 4s2, and chromium 3d4 4s2. It's supposed to be 3d4 4s2, but it is exceptional. It is becoming 3d5 4s1 just for maximum stability. Okay, so here chromium and copper, in case of chromium and copper only we will see the differences. See, in case of copper, I am going to tell you, in case of copper also, this is copper. So in case of copper, it is also 3d10 4s1. So in case of chromium, again chromium, it is 3d5 4s1, and copper 3d10 4s1. Only chromium and copper are the two elements in which there is 4s1. Rest in all the elements you can get 4s2, 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 4s2 is there. Okay, 4s2, 4s2, 4s2. Here is 4s1, exceptional. 4s2, 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 4s2. Then copper is also 4s1. After this, after electronic configuration, we have general electronic configuration of the transition elements that now you practice. There is one question that is coming in the mind, that how are D block elements and transition elements different? How are D block elements and transition elements different? So it is very simple, dear students. All D block elements are not transition elements. All the D block elements are not transition element, but all the transition elements are D block element. Hope so you understood. सारे ट्रांजिशन एलिमेंट्स वो जो है वो डी ब्लॉक होंगे, लेकिन ये ज़रूरी नहीं है कि सारे डी ब्लॉक जो है वो ट्रांजिशन एलिमेंट होंगे. इसका मतलब है देर आर सम ऑफ द डी ब्लॉक एलिमेंट्स विच इज़ नॉट ट्रांजिशन, which is not partially filled, they are fully filled. All D block elements are not transition element because D block elements like zinc have fully filled D configuration. So their ground state as well as their common oxidation state, which is not according to the definition of transition element. That's why these are not transition elements. Only those D block elements are known as transition elements, which is somewhere in partial, okay, incomplete. So general property of D block element, if we'll say, so basically we will study in this presentation atomic and ionic size, ionization enthalpy, oxidation state, colored ion, catalytic property, magnetic property, formation of complex compound, formation of interstitial. Maximum question, this is most important part, physical properties of D block elements, because maximum question, that is reasoning type question, that will come from these periodic table, okay, these periodic properties. So general property of D block element, atomic ionic size, ionization enthalpy, oxidation state, colored ion, catalytic property we are going to do. So first, melting and boiling point. If we will talk about melting and boiling point, which is called enthalpy of atomization. Melting and boiling point is also known as enthalpy of atomization. So if we will talk melting and boiling point, which is high in this particular D block element, a large number of unpaired electron are take part in bonding, so they have very strong metallic bond. Hence, if it is having strong metallic bond, so you know metal have high melting and boiling point. So here if we will talk about some of the groups, so you see scandium, titanium, vanadium, titanium, from titanium to chromium, the melting point and boiling point is increasing, then it is decreasing up to manganese, because now all the orbitals are incompletely filled. Then it will still increase for iron, then cobalt to nickel it is same, then again it is decreasing. So this, which is this graph, which is representing this graph, which is representing the up and down, that will clear the melting point and boiling point, okay. So in the hafnium you can see continuously it is increasing, then continuously it is decreasing. So with the help of this chart, now it is my request that you all will make this kind of chart of melting and boiling point from your book. Atomic and ionic size, first it is decreasing, then it is increasing, constant, sorry. First you can see it is decreasing, then it is constantly increasing, okay. So it means that scandium, titanium, vanadium, chromium, manganese, up to manganese first it is decreasing, the atomic size is decreasing because it is moving from left to right, and left to right atomic size is decreasing. But after manganese, iron, cobalt, it is continuously slightly increasing also. So atomic radii of fourth period transition element are first decreasing, then increasing. So this is why it is given with the help of atomic size also. So you will make this graph also. Try to understand this graph, what is there. First is decreasing, then it is increasing, okay. Up to manganese it is decreasing, then after manganese it is increasing. So why it is happening? Because of again the incomplete orbital, whereas in manganese maximum incomplete orbital is there, 6 incomplete orbital is there. Here 5 4 3 2, like this way 1, and this side again 5 4 3 2 1, it will decreasing. That's why atomic size is decreasing. Next is along the row nuclear charge increases, but the penultimate D subshell has poor shielding effect, so atomic and ionic size remain almost same. Whereas the radii of the third 5D series are virtually and same as those of the corresponding number of second series. This phenomenon is associated with the intervention of 4f orbital. The filling of 4f before 5d orbital result in a regular decrease in atomic size, which is called lengthenide contraction, because in fourth f block element is introduced, which is decreasing because of lengthenide contraction. Lengthenide contraction is what? It is with the increase in atomic size, the decrease in atomic, with the increase in atomic number, decrease in atomic size. That is called lengthenide contraction, or you can say with the increase in atomic size, with the increased atomic number. The net result of lengthenide contraction is that the second and third D series exhibit similar radii, like zirconium and hofmanium. They have almost similar radii. That is due to lengthenide contraction. It is the property of lengthenide contraction. Ionization enthalpy. Ionization enthalpy is, it is the amount of energy required to convert a simple metal into ions. Okay, yeah, to reduce the electron from outermost shell. It is first increasing, then slightly remains same, then suddenly increasing. So first ionization energy of fourth orbital, it is vanadium has greater ionization enthalpy than chromium, then decreasing magnesium, and nickel have greater than copper, then copper has less than zinc. It means that again chromium and copper is the exceptional cases. Okay, and due to the increase in ionic charge which accompany the filling of the inner d orbitals. Try to understand, there is an increase in ionization enthalpy along each series of the transition element from left to right. So it means that it is increasing, ionization enthalpy is increasing with the decrease in atomic size. However, many small variation occurs. So after this oxidation state, if we will tell oxidation state, so next if we will talk about the oxidation state is what? It is the transition element which have variable oxidation state. This is one of the important property, variable oxidation state. Variable mean variety of oxidation state due to very small energies difference between n-1d and ns subshell. So scandium have +3, titanium have +2 to +4, vanadium have +2 to +5, chromium have +2 to +6, because chromium have maximum number of incomplete orbitals. Manganese have +2 to +7. So this is the variable oxidation state, you can say. There is variety of 6 different orbital. Okay, then iron decreasing, cobalt 2, 3, nickel 3, copper 2 have. Zinc have only one oxidation state. So zinc and scandium have minimum oxidation variability, then it is increased. So the element which give the greatest number of oxidation state, that is occur in or near to middle of the series. Manganese, for example, exhibit all the oxidation state from +2 to +7. There is low oxidation state which is found in complex compound, which is ligand capable, and pi acceptor character is there, and in addition to sigma bonding. It means that this is forming complex structures, mean big structure it is forming due to variable oxidation state. It is the one of the very important property of D block element, that when it is forming a compound, it will form colored compound. All those colored compound, colored salt in the lab, that is made up of D block element. Okay, so most of the transition metal compound are ionic as well as covalent, and they are forming colored both in solid state as well as in aqueous state. Generally the element which have unpaired electron, that produce colored compound. Generally the element having unpaired electron, या partially filled electrons or transition state, these are forming colored compound. So next is, you can see here some of the example of colored compound. Pay attention. Scandium oxide is white, titanium oxide is I can say pale yellow, pale white. Vinyl sulfide is a little bit green. Sodium chromate is yellow. Manganese chloride tetrahydride is pale yellow. Potassium ferricyanide is red. Cobalt is maroon. Nickel is green. Zinc you can see white. Copper is blue. So it means that all these colored salt are due to the unpaired electron or unpaired orbital, whereas all the white are due to paired diamagnetic property. It means that very simple, paramagnetic shows colored, diamagnetic will show non-colored substances. Okay, so these are the range from where the color will represent. Violet will come when their wavelength is between 430 to 400, and blue it will show when between 430 to 480. It will give green between 480 to 560, yellow between 560 to 590, orange between 590 to 630, and 630 to 750 it is red. So it is giving basically bibgyor. It is the rainbow color. Bibgyor: violet, indigo, blue, green, yellow, orange and red. Okay, so these are the color. And violet color, this chart is giving the information about the wavelength. Because of that the color are there. So the next property that is of D block is catalytic property. What is catalyst? Now you know they are only participating just to promote the reaction or act like a poison. So these are all from D block elements. Vanadium is from D block, and iron is from D block, nickel is from D block, cobalt is. If application, I will say vanadium oxide will use in contact process to prepare H2SO4. We have just recently did in previous chapter. Finely divided iron is used in Haber process. This also we did. Nickel is used in hydrogenation process. Cobalt used in gasoline process. This property is due to presence of unpaired electron. See, all the compounds are colored due to unpaired electron. The property of transition element are catalytic due to unpaired electron. Why D block elements are called transition? Because of incomplete orbiter of D block. So this is very important logic, or I can say reason, to find that the variety of properties in D block elements are very important property, that is due to unpaired electron or variety of oxidation state. Okay, so variable oxidation state is also one of the reason to form the catalytic property. Presence of unpaired electron is also one of the major reason to form catalytic property. In most cases provide large surface area which have free valency, that is also one of the reason for catalytic property. So thank you, this is all about for today. Hope so you enjoyed all the properties of D block elements. Now in my next video I am going to tell you about the reason and reasoning and logical type questions, and we will discuss the F block elements also. So how it is producing the D block element. An important compound of D block elements that is related to potassium dichromate, the compounds of chromate. Okay, so till my next video, take care yourself. Thanks for watching this video. Thanks for listening me patiently, and hope so you enjoyed and you understood. Thank you. Have a nice day.